This is going to be a lesson on finding the lengths of circular arcs. Now, if you started off with a picture of a circle, an arc is defined as a portion of its circumference. Now, throughout this lesson, I'm going to refer to the length of the circumference as c and the length of the arc as s. Now, to figure out the length of this arc, you're going to need the radius and the angle between the two endpoints. So just to clarify, we want to find this length s over here, given r and theta. Now, finding the length of this arc s isn't actually so hard, and to show you this, I'm going to start with an example. Suppose we started with some cylindrical can. We'd like to place a sticker around this can, but we don't want to go all the way around. We'd like to stop at some distance. Now, the first thing we want to do is to project this circle into 2D so that we can actually measure it. Now, when we measure this can, we notice that its radius is exactly 3 centimeters. We said that we wanted the label to cover 3/4 of a whole revolution. If we go ahead and draw on the whole circumference, we're going to notice that this is also going to be 3/4 of the whole circumference. Now, we know that the length of this whole line is just equal to the circumference of the circle. Now, as you can see, once we've rolled this out, this section over here accounts for 1/4 of the circumference. So this is also 1/4 of the circumference. And this section over here is what's left. So this section is also what is left. Now, this shows us that if we want 3/4 of a revolution, we should also take 3/4 of the circumference. Now, earlier we've already showed that the circumference is just equal to 2 pi r, so we can substitute that. Now, we know that the radius of the can is just 3 centimeters, and now we have something that we can put into our calculator. And this over here is a general way to find the arc length of any arc. First, you just go ahead and find out the fraction of the arc that you want, and then you multiply it by the circumference. Now we should go ahead and repeat this in the most general case. Now, it turns out that the formula is going to be particularly simple if we express our angle in radians. If we know that we have theta radians, then we first need to remind ourselves how to convert radians into revolutions. So if we know that 2 pi radians is equal to 1 revolution, we can divide both sides by 2 pi to say that rad is the same thing as 1 on 2 pi revolutions. So if we have theta radians, then we actually have theta on 2 pi revolutions. Now, as we saw in the example, the arc length is just equal to the circumference times the number of revolutions that we have. Now, the number of revolutions we have is just theta on 2 pi, and the circumference is just 2 pi r. And as you can see, we can just cross off the 2 pi's. And this gives us our final formula for the length of our arc. But you do have to be careful if you're going to use this formula because we've assumed that theta is in radians. So if you're going to use it, make sure you put theta in radians. So we can bring back our example from before just to show you how this would work. Let's get rid of all of our unnecessary working out first and just keep the answer. Now, the first thing to do is just to get the angle in radians. We know that rev is just the same thing as 2 pi radians. And if we simplify this, we're just going to get 3 pi on 2 radians. Now, we know that s is just r times theta. So if we just go ahead and substitute the radius and the angle, we'll get our final answer. Now, if we just plug this into our calculator, we'll notice that this is also going to give us 14.1 centimeters. And this completes our example. Now, there is actually one final remark to make. When we divide the circle up into arcs, there are actually 2 arcs that we could form. We name the smaller arc the minor arc, and we name the larger arc the major arc. To get the angle of the major arc, you're just going to take the angle of the minor arc and then subtract it from 2 pi radians. So when you are using this formula, pay particular attention to whether you're dealing with a minor arc or a major arc. And with this, we've actually completed our discussion on arc lengths.